Hello, all you math 10s out there, you little mathematicians. So it's Mrs. Schwartz here. We're going to look at lesson 4, parallel and perpendicular lines. So we've already looked at parallel and perpendicular slopes and line segments thus far back in the last unit, but we're just going to review that and build on that a little bit. So as you can recall, we know that parallel lines have slopes that are equal. Okay, so of course, if I have a line that is a positive sloping line, and recall that we read our graph from left to right, right? Just like we read a book, we read our graph from left to right. So this would be a positive sloping line, and let's just say the slope of that line was, I don't know, 3/2. Then a parallel line would also have the same equivalent slope of 3/2. Okay, those are parallel lines, and if you can recall, those little symbols mean they are parallel. Perpendicular lines have slopes that are, we call it the negative reciprocals of one another. Okay, and that doesn't mean they're both, that does not mean that they're both negative. Recall, if I had a slope of a line, let's just use that same one. If our slope was 3/2 positive, then the negative reciprocal, remember the reciprocal is just when we switch the numerator and denominator, and our perpendicular slope would be a -2/3. So if we had this line up here, one of these lines or both of these lines, and we were to draw a perpendicular line, it would then look like that. Okay, and this would be, of course, a right angle. Or en français, un angle droit. My grade 3 child is learning about right angles, so, and he's in French immersion, so they call it the angle droit, the right angle, the angle right. Anyway, it's kind of funny. Another thing to keep in mind, if we are looking at a slope of a line, say it was negative to start with, okay, this one here would then be -2/3. If we started with a negative slope, you know, like negative, I don't know, 3/5, then the perpendicular slope, right, the slope of the perpendicular line would be positive, okay? The slope of the perpendicular line would be positive 5/3. So if it was negative, the perpendicular one is going to be positive. And if it was positive, the perpendicular one is going to become negative. So that probably makes sense, and I'm hoping you've drawn many of those conclusions on your own as you've done your assignment booklets, etc. Look at the next example. It says, state the slopes of lines that are parallel to and the slopes of lines that are perpendicular to each linear equation. Now, Mrs. Schwartz kind of cheated a little bit, and I added a couple of grids here because I'd like to, we're going to look at the equations, but I'd also like to look at the grids so that you're comfortable with graphing. Okay, you need to be able to draw a straight line in grade 10, and it's critical to go on to grade 11 to be able to do that. So let's look at this first equation. Now, remember, we've already done this with Mr. Wickens. He went through and explained and taught you guys the slope y-intercept form. So that was the point y equals mx plus b, where the coefficient of x, okay, the coefficient here is our slope, okay, the coefficient of x when the line is drawn in this form, and the b value is our y-intercept, okay. And for those of you who looked at the video on, or for those of you who understand how to find x and y intercepts, if I were to make x 0 here, right, if we said, look at this equation, if we were to just look at the equation y equals mx plus b, and if we were to let x be equal to 0, okay, if x were 0, then 0 times anything would be 0, and we would see that y is equal to b. So that's how we know when x is 0, y is, of course, this constant b value, which we call our y-intercept. So let's, excuse me, let's look at this equation down here. If we look, this equation is in slope y-intercept form. This is in y equals mx plus b form. So if it's in this form, we look here and let's find this coefficient of x is the slope, and the constant 3 is our y-intercept. And again, that's because if I take this equation, okay, if we took this equation and we said, okay, this is a good skill to know. If let x equals 0, then we would say, well, y would be equal to negative 1/4 x plus 3. Okay, well, that's y equals negative 1/4 times 0 plus 3. And anything times 0 is, of course, 0. So this little guy would just, this term would just cancel, right? We're just gone with him. 0 times negative 1/4 is just 0. So we would be left with y equals 3. So that means we know when the x value is 0, the y value is 3. And of course, where is our x value 0 and our y value 3? On the y-axis. So that's why we know, again, that this is the y-intercept. So I just want to review that quickly. I know you're probably really starting to make those connections. So we can sketch this, even though it doesn't say to sketch it. But it says, what is the slope of a line that is parallel to and perpendicular to each line? So first thing, let's start by drawing this line. So how do we start by drawing it? We find the y-intercept, okay? We find our b value, which is 3. Okay, 0, 3, which is right here. Okay, there's that y-intercept. This is my y-axis, and there's my x-axis. And so once I know that that point is there, I know that I can find infinite other points. And when we look at this negative 1/4, I always say in class, I always say, we're just going to suck that up. We're going to suck that negative. That's a negative 1/4. Okay, it's the same thing as negative 1/4 in the front, but where does that negative really go when we draw and we want to find our next line? So the way I usually say it is I say, if the rise is negative, okay, if this rise here is negative, I'm going to fall, okay? It's rise over run, but if my rise is negative, I'm going to go down, and I always run right, okay? So I'm going to go down 1 and right 4. So of course, if I start at this point here, my 0, 3, and I go down 1 and right 4, that allows me to find my first point. Now, of course, I can go down 1 and right 4 again, and down 1 and right 4 again. I'm off the grid a little bit there, but we could go forever. Of course, if I wanted to go in the other direction, I could go up 1 and left 4, the exact opposite. But to find my first point, once I go from my y-intercept, I follow the rule of I rise down or I rise up and I run right. Okay, so of course, hopefully, and many of you are probably figuring out those connections and making those connections as you go through and do your homework. So there would be a line, the line, okay? So then it just says state the slopes of lines that are parallel to. So a parallel line would have the slope, the same slope, okay? So a parallel slope would be equal to negative 1/4, and a perpendicular slope would be the negative reciprocal. So this is negative. The negative reciprocal of negative 1/4 would be positive 4/1. So there's really the answer to our question, but I do want to go up here and I want to draw a negative 1/4 parallel line again. I know that you're coming along and doing that just nicely. So let's find any y-intercept. Okay, I'm going to find, like, I'm going to use negative 3, and I'm going to go down 1, right 4, down 1, right 4. Same slope. Oops, Mrs. Schwartz has just got the old eyes, so I can't really see. Sorry, that was spot. So let's do this. Let's draw this line. Okay. And there we go. There's a parallel line. And now a perpendicular line. We could go from any point, anywhere, pretty much. And let's do that. Let's try green dots here. So I'm going to go down here, pick a point, and I'm going to go up 4, right 1, up 4, right 1. Okay, I'm rising 4 and I'm running 1. And again, up 4, right 1. If I wanted, I could go in the opposite direction. I could go down 4 and left 1 to find other points that are in a different, on the other on the left-hand side of that initial point, okay? So I always find the first one though by following the up and right or down and right rule. Now let's draw that line, okay? And of course I know you didn't necessarily have grid paper, but you can either sketch that or just follow along, and as long as you understand, that's probably good for now. Okay. The first thing next thing I want you guys to do is I want you to pause the video, and I want you to try changing this to y equals mx plus b form. Now, why is that? Because right now it says we want to know the slopes of lines that are parallel and perpendicular to this line. This is a linear equation right here. This is linear. I know it's linear because the degree on both of these is equal to 1. Okay, the degree is equal to 1 on both of those. I know I can change it into y equals mx plus b form, but how to do that? So I want you to pause the video and just try changing it to y equals mx plus b form, because I think that a lot of students need that practice. Okay. Okay, in order to change this to y equals, we're going to move over everything that is not with the y. I'm going to move that over to the other side of the equation. And when I move it over, the sign changes. So on the left-hand side, we are left with our 5y. On our right-hand side, when I move over the 2x, 2x, which was positive, becomes negative 2x, and 1 that was negative becomes positive 1. Okay, and now I want to isolate that y, so I'm going to divide everything through by 5. And we get y equals negative 2/5 x plus 1/5. Now, this one would be difficult, a little bit difficult to draw, of course, using the slope y-intercept form. That's why there's other methods, right? That's where there's the finding the x and the y-intercept, okay? Because of course here my y-intercept is 1/5. That would be a little bit dicey to find, 1/5, 0.2, right about there, okay? And then the same process would apply, right? We would go down to 1, 2, and then right 5, okay? Our slope is, right? Our rise here is a negative. So we're going down 2, and then we run 5. So down 2, 1, 2, 3, right? Down 2, 1, 2, 3, 4, 5. So we're not right on the grid. So that's not a perfectly nice line to draw, is it? But that's okay. Not the end of the world. We find those points right through there. There's our 2. We only need 2 points to draw a line, and there's our line, okay? This kind of looks like it's going through the origin, so let's fix that a little bit. It should be more like, like this, right? Let's see, that's better. Okay, and so there's our first line. And we're not going to have you draw too many weird ones like that. So of course, though, what is our slope here? We see that this is our slope. We know that's our slope because now our coefficient of x is negative 2/5, so there's our slope of negative 2/5, and a parallel slope would be also negative 2/5, right? And a perpendicular slope would be the negative reciprocal, which is just when we take the opposite sign, okay, it would be positive 5/2, okay, positive 5/2. So we could take any other line, and I could take a nice y-intercept for another line, and I could, here's a negative 5, and I can go down 2, right 5. There's another parallel line. So let's draw that one. And these two guys, oops, let's see if I can make that work. Good. And of course, we can put these little extra arrows in. That means that those lines are parallel. And if I wanted to draw a perpendicular line, I'm going to rise 5 and run 2. Okay, my first point, and I can take any point anywhere. They're not saying it has to go through a specific point, so I'll just choose a point, and I'm going to rise 5, 1, 2, 3, 4, 5, and run 2. Whoops, that's not really on the grid. And let's draw that line, and there I can see that those lines form really nice right angles. Okay? Let's do one more quick question here before I pause the video again. This one says a line passes through the points P 2, 3 and Q negative 1, 7. Determine the equation of a line in slope y-intercept form that is perpendicular to this line and has a y-intercept of negative 3. So let's think of our slope y-intercept form. Okay, we know that that's y equals mx plus b. We want to find that equation, but of course we need to fill in two things. We need the slope. Okay, we need to figure out what the slope is. We need to know what the b value is. What's that constant when x is 0, what is y, right? That's our y-intercept. So I'm looking at the y-intercept, and they tell us in the question that the y-intercept is negative 3. So we can just plug that in here. Mx minus 3, or we could just, let's leave the m blank for now, I guess. Okay, so we know that our b value is negative 3. What goes in for m? So we know that there's some other line that passes through the points 2, 3 and negative 1, 7. It says, what's the equation of the line that is perpendicular to this line? So I need to know the slope of this line first. What's the slope of that line? And this new line that I'm coming up with the equation is going to be perpendicular. So how do we find the slope? Well, the first way, let's do this in two methods, okay? First thing we can do is we can use our formula for slope, okay? And what's our slope formula? Our slope formula is y2 minus y1 over x2 minus x1. And remember, that's rise over run, right? The rise is our y values, right? These are the y values. There's our, right? The rise is our vertical, and the run is our horizontal. So rise is y and run is x. So that's why we're rise over run is another way of writing slope. Okay, so of course our formula here says subtract our y values and then subtract our x values. Okay, and as long as we're consistent with our order, we're good to go. So I'm going to go 7 minus 3 over negative 1 minus 2. So we have to make sure that we're grabbing the correct coordinates, of course, which we all know that x and y are not the same. So that's going to be a 7 minus 3 over what do we have here? Over negative 1 minus 2. Okay, negative 1 minus 2. So we're going to be careful with our integer rules. And I think, what do we get here? We get 7 minus 3, which is, of course, 4. And negative 1 minus 2. If I've lost $1 and I've lost $2, how much have I lost, Elton? 3. So what's the answer? Negative 3. Negative 3. Elton's popped in for a little math lesson. So 4 over negative 3. Okay, or we can rewrite that as negative in front, 4 over 3, or we can write that as negative 4 over 3. Those all mean the same thing, right? So sometimes we get confused with those negatives and where to put it. You can actually put it anywhere, in the front or on the top, on the numerator or the denominator. Normally in math, we will not see it written on the denominator left there. It would often be like this, the middle one here in the front or in the top. Now I like to suck it up, Buttercup. And why do I do that? Because I want to be able to draw my picture. So I would say my slope is negative 4. So I would fall 4 and run right. Now, let's look here. So this is the slope of these 2 points, which is 2, 3, negative 1, 7, which is negative 4 over 3. I need the perpendicular slope. So my perpendicular slope is going to be positive 3 over 4. And that's what's going to go into my equation, y equals mx plus b. So there's our equation, y equals 3/4 x minus 3. Now, we can draw, another way to have found that slope, which I meant to mention, is we could have actually looked at the points 2, 3. So 2, 3 is right here. Okay, there's the point P 2 comma 3, and negative 1, 7. Negative 1, 7 way up here. There's my point Q. Negative 1, 7. And if we draw this like that, right, there's a line. There's our line that the graph talks about. It says a line passes through these points. What's the equation of a line that is perpendicular? So if you had a grid, you could always draw that. And let's see, what's our slope? I start at the left point and I'm going to go down. I always do my rise first. Okay, so I'm going down 1, 2, 3, 4 because that's the number that goes on top. I do my rise, then I do my run. 1, 2, 3. So our slope here, of course, which we already solved for, was negative 4 over 3. So our reciprocal, negative reciprocal, positive 3 over 4. If I wanted to draw this line over here that we just found the equation for, we would go down, we would find that y-intercept. Okay, we're going to start at that negative 3. Because when x is 0, y is negative 3, and I would rise 3, 1, 2, 3, 1, 2, 3, and run 4. 1, 2, 3, 4. There's another point, and there's my perpendicular line. Okay, so we kind of did more than was necessary for those questions. It just said, what's the slope? You know, it didn't say to necessarily do it 2 ways, but I think it's good that you can see this and understand that there's more than one way to do these questions. Okay, now I'm going to get you to, excuse me, pause the video again. Down here, there's a question here talking about slope point form. Okay, I've X'd that out. We're not doing that. That's one of the concepts we're going to skip in Math 10. It is not the end of the world. It's not something you really see in Math 20 or 30. Really, it's not. So we've decided to skip that just to sort of cut out a few concepts so that to make things a little bit easier from home. But one thing we do need to be really good at is rearranging the equations and sketching these two guys. Now, this is in review to what Mr. Cito would have taught you back on page 13. Okay, he did these graphs with you. If you need to go back to page 13 and review them, but I'm going to ask you to pause the video and do these two questions. So I want you to rearrange 3y minus 12 equals 0. And I want you to rearrange 4x plus 16 equals 0. And then you can draw a little sketch of those, okay? This is excellent practice. If you do this and you understand, then great. If not, contact your teacher, haha. Or come to a homework help session and just ask some questions, okay? So I'm going to put the grid there, but now once that grid's done, I'm going to ask you to pause and try to rearrange these yourself. So this one you're going to solve for y equals, number 1 you're going to solve for y equals, and number 2 you're going to solve for x equals, and then see if you can graph those, okay? Give them a try right now. Okay then, so what I did was I moved over my negative 12 and I got a positive 12, and then I divided both sides by 3 to solve, and I got an y equals 4 for question number 1. Now, if we think back, let's put this back into something we know. We know that the line y equals mx plus b forms a linear graph, it's a linear function. And if I think of this y equals 4, if we were to place, now there's no x term there, there's no x variable, there's no term with an x. So if I were just to kind of place these values in here, I've got y equals, the b could be the 4, right? There's my constant. But what happened to this here? Well, of course, my slope was 0. And we know 0 times anything is 0. So that's why if our slope is 0, right? If you're walking down the hallway, your slope is 0. That's a horizontal line. Okay, now let's think back. Here's our x-axis and here's our y-axis. My y-intercept is 4. 1, 2, 3, 4. So we're just doing a quick sketch here. And I'm drawing a line with a slope of 4 through the y-axis at 4. Okay, and that is my y equals 4. So this should be review from the other day, and it probably mostly is. Okay, so there's our y-intercept of 4. Now, just a reminder, if we were to move down and draw just a few other lines. Okay, for example, if I drew this line, this would be, whoops, that would not quite be y equals 2, sorry. Okay, here would be y equals 2. Okay, and here would be y equals, ooh, I'm on the x-axis. What would my equation be there? It would be y equals 0. And so the equation of the x-axis is in fact y equals 0, because no matter where you are on the x-axis, we're not going up or down, y is 0. Right? I've got a point over here of negative 52 and 0. I've got a point way over to the right of, 18 and 0. So now, no matter where I am on the x-axis, y equals 0. So the equation of the x-axis is y equals 0. Pretty fancy. Okay, let's go on. Whoops, for some reason I'm freezing up here. Let's move this down. Let's move this one. Okay. And this one, we moved over our positive 16. And we know that when we move a term over the equal sign, it becomes negative. So 0 minus 16 is a negative 16. And when we divide both sides by a positive 4, because we were left with 4x equals negative 16, we get x equals negative 4. Okay, x equals negative 4. So this, in fact, cannot be written in y equals mx plus b form. So we know it is not our regular kind of graph. It's not a function. And a graph that is not a function, well, we remember, if we think about the linear, the vertical line test with that y equals negative 4 is going to go, x equals negative 4 rather is going to go right here. Okay, and this is a special line. It is in fact linear, but it's not a line in the form of y equals mx plus b. The slope is undefined. Okay, the slope is undefined. So this is just a very weird one, okay, that we have to kind of memorize. When we see x equals, we know, hey, that can't be written, right? We have to think to ourselves, cannot be written in y equals mx plus b form. Okay, now we would have, if we were in class, introduced ourselves to the graphing calculator, and when you go into your graphing calculator under the y equals, right, only functions can be graphed in our graphing calculator. So this is not a function, right? So therefore this is not a function. And the definition of a function was any value for which we put in an input, we get out one and only output. And in fact, if we move along this line, if I put in an input of negative 4, I can get negative 4 comma 0. I can get negative 4 comma 1. We can get negative 4 comma 57 way up there. That's a weird scale. Or we can get down here, negative 4, negative 3. Okay, or 13 maybe, whatever the scale is. So no matter where I move, whatever my input, I'm getting different outputs. That's why that's not a function. And remember, the vertical line test said if I draw a vertical line anywhere over my graph, right? If we draw a vertical line over a graph somewhere, and in fact, let's try drawing, can we draw a vertical line over this graph without touching more than once? Well, of course we can't, because it is a vertical line. Right? The vertical line test, we've touched infinite times, not just more than once, infinite times. So we would say here, okay, vertical line test, right, touches more than once. Therefore, not a function. Okay, so there's a few reasons we know and that we're figuring out that it's not a function. Okay, hopefully that helps. Let's go down. We're going to do a couple more examples here. I know there's a lot of examples. I would like to take you through a few. You don't necessarily have to write down every one, but I wouldn't hurt to go through. I'm going to get you to try a couple as well. So the next one says, determine the equation of a line that is parallel to the line through A07 and B42 with the same y-intercept as the line 2x minus y plus 4 equals 0 in slope y-intercept form. So let's start with slope y-intercept form. That's y equals mx plus b. So what do we need? We need to put our slope in there, and we need to put our y-intercept in there. Now, where do we get the slope and the y-intercept? We need to find our slope. Well, we are told that the points A, 0, 7, okay, and B, 4, 2, our slope is going to be parallel to that line segment, or the line that goes through those 2 points. So I need to figure out what's the slope of AB. Okay, well, I could draw that in a graph, but we can also just do that algebraically. Might be a little less work, so I did a lot of review up above, so we'll just kind of cut to the chase here. So I've got 2 minus 7. Okay, this is, of course, my point 1. Okay, I'm calling this point 1. Okay, so this is x1, y1, and this one over here I'm calling x2, y2. So I'm going to go y1, right? Our slope formula, just to remind us, is y2 minus y1 is the change in the vertical rise over the change in the horizontal run. Okay, so 2 minus 7 all over, okay, I'm going to be really careful with my order, 4 minus 0. I couldn't do 0 minus 4. It has to be, if this is 0.2, it's 2 minus 7 and 4 minus 0. Okay, which is negative 5, of course, right? 2 take away 7, negative 5 over 4 minus 0, 4. Okay, so it's got the same slope. So I know already over here I can fill in y equals negative, let's plug it in with let's plug it in green, we'll match here, negative 5/4. We need that x in front, okay? That's the coefficient of x is negative 5/4 plus b. Now I need to find the b value, okay? The b value is the y-intercept, right? So here was our slope, and now let's find the y-intercept, okay? B is the y-intercept, and that's the y-intercept of this line here. It says it's got the same y-intercept. Can I see the y-intercept for this line? Is the y-intercept 4? Is it? Is b equal to, no, because we have to change it into y equals mx plus b form. So 2x minus y plus 4 equals 0. Now I know that you guys, I know that we all know how to, we're starting to get really good because we did this in grade 9 and 7 and 8 as well, manipulating equations. So in grade 10, I like to teach you that we just move everything over. If you want to work down, that's fine as well. So when I move things over, the sign changes. What are we left with on that left-hand side though? We're left with a negative y, okay? We're left with a negative y. So we've got negative y equals negative 2x minus 4, right? My positive 2x becomes negative 2x. Positive 4 becomes negative 4. And now I've got all these negatives. I got a negative y. I don't want to solve for negative y. I want to solve for y. So I'm going to divide through by negative 1. What I do to one side, I have to do to the other. And now, of course, the two y's, the two negatives there on the y and the negative 1 cancel. We get y equals, negative divided by negative, positive 2x, negative divided by negative, plus 4. Okay? So now, this is the y-intercept. By coincidence, it ended up being a 4, but that's not always the same. Okay? B equals 4. Okay, there's my y-intercept of 4. So we could actually have used that value, but that was just a coincidence because oftentimes it doesn't work. And the reason it did work is because we didn't have to divide y. The coefficient of y was just a 1, and it was a negative. And because we moved the 4 over, it became a negative 4 divided by negative 1 was positive 4. So coincidence there. Another way to have solved this, just for those little keen beans, another way to have done this maybe quicker, we could have said, some of you might be thinking, well, why didn't you just move the y over, Mrs. Schwartz? So we could have done this. Okay, I've got 2x minus y plus 4. Instead of isolating the y, getting everything else away from y, I could have just moved that negative y over as well, okay? So don't be afraid to just move things around. And now we've got 2x plus 4 equals y. So there's our slope y-intercept form there. It's just written backwards, right? We've got mx plus b equals y. Same thing. Okay, see the try here. I'd like you to try this next question. I'm going to pause the video and I want you to try this next one. Okay, let's go through this one together. Determine the equation of a line that is perpendicular to the line 4x minus 6y minus 12 equals 0. If you got a chance to start this, that would be great. And it passes through the point P0, negative 1 in general form. Now, two things. Right away, I notice, well, a bunch of things. I notice we're looking for a perpendicular equation to this line. So I know I'm going to have to find the negative reciprocal. Okay? I'm going to have to find the negative reciprocal. The other thing I notice is that it passes through the point P0, negative 1. So this tells me that when x is 0, y equals negative 1. So that is the y-intercept. So I already have the b value. Okay, they're just not giving it to us in direct language, but that's it. It's hidden there. And I know that I want to find this and I want to put my answer in general form, which we did in the last unit. So let's take a look here. So let's take our equation. Do you think that this 12 would be our y-intercept? I don't think so. Let's look at this equation, okay? And the reason I know is because this y has a coefficient that we're going to end up dividing the 12 by. So I know I'm not going to get a 12 as my b value. Okay, remember that was just a coincidence up here, okay? Don't be thinking that's the y value every time. Okay, let's just do this. Let's move over. So I'm going to move over my 4x. And we're going to move over our negative 12. Okay? And I don't have to rewrite it necessarily because I know what are we left with on the left-hand side here? We're left with a negative 6y. It's the sign in front. It goes with that number. So that's a negative 6y equals, on the other side of the equation, now I'm going to have a negative 4x. Positive 4x became negative 4x, and negative 12 becomes plus 12. So I know you guys can move those over. And now we're going to divide everything through by negative 6. And we're going to be really careful with our integer signs. Okay? Negative 6 divided by negative 6 is, of course, 1. So we're left with 1y. And now we've got two negatives which are going to cancel. And 4 over 6 can reduce to 2 over 3. Right? Both divisible by 2. And 12 divided by negative 6 is a minus 2. So here's our slope of this line here that was given to us. Here's our slope of this line. Notice our y-intercept is actually negative 2, not negative 12. Okay, so that rule up above is debunked, or that coincidence. So here's our slope of 2/3. We want the negative reciprocal. So our negative reciprocal of 2/3, the slope is going to be, perpendicular slope is going to be negative 3 over 2. And we know that our y-intercept was negative 1. So let's start with that. Now I'm going to write y equals negative 3 over 2 x minus 1. Now that's all great. Okay, that's all great. I'm just going to shrink this down a little bit. There's nothing wrong with that. That's fine. We're getting there. But we want the answer in general form. So if I want this in general form, I need to get rid of this little fraction. Because general form, remember, that's ax plus by plus c, which is my constant, equals 0. Don't forget to write the 0. We always need to have something on both sides of an equation. If there's nothing on one side, put 0. Don't be afraid to put 0. Okay? C is our constant, and my a value must be positive. So first thing I know, and there's no fractions. A, b, and c must be whole numbers. Okay? Now, if I multiply everything through by 2, I'm going to multiply every single fraction by 2, or every single term by 2, I should say. So what happens when I multiply y by 2? We get 2y. Negative 3 times 2 divided by 2. Well, if I take a number and times it and divide it by the same number, I'm left with that number. So we've got a negative 3x. And negative 1 times 2 is, of course, minus 2. Now I want everything on one side of the equal sign. When I do this, I always look for what is negative, okay? If that's a negative 3x, I'm going to move everything. He's the guy that decides for me whether I move everything to the right or the left. I need to make him positive. He's going to the left. Therefore, the negative 2 is also going to the left-hand side, okay? Negative 3x becomes positive 3x. And then the 2y is there. I leave my 2y. He's positive. I leave a plus sign. It's positive plus. And then the negative 2 becomes a plus 2. And what are we left with on the right-hand side? Nothing. So we write a big 0. Okay, we don't leave it blank. Don't leave it hanging. Okay. There we go. There is our nice little general form equation. Okay, let's look at one more. I know this is a lot of stuff, but I think that some of us really need the practice, and I think that to go through these lessons, if you want to stop and if you feel like you know enough and you want to start and just do your assignment, that would be great, but otherwise I think we could go through and try a couple more. Okay, we'll fast forward. At the end, I'll tell you what questions I think we should do on this lesson, okay? Okay, and I know this is a lot, so you might have to contact your teacher, get a little extra help, that's fine. We'll get you started. Let's look at this next example. Determine the equation of a line that passes through the point P negative 1, 2, and is parallel to the y-axis in general form. Oh boy, parallel to the y-axis. So let's think this through. Okay, I'm going to draw a little line. Okay, think it through or draw it, right? I think a lot of times on tests, students will be like, oh, I just need some grid paper. So there we go. There's our x and y axis. So a line that goes through P negative 1, 2. It's weird how that's kind of split up like that. But anyway, that's point negative 1, 2, and is parallel to the y axis. So let's find the point negative 1, 2. Okay, negative 1 and 2 is right here. Okay, that's negative 1, 2. So there's our point P, and it's parallel to that x-axis. So, sorry, parallel to the y-axis. It would help if I could read. Okay, parallel to the y-axis. So parallel to the y-axis, right down there. There's my point, parallel to the y-axis. Now, let's think about this for a second. Vertical line test, it's going to touch more than once. Is this a function? No, it is not. It goes through the x-axis at negative 1, right? Right there through negative 1. And so the equation of that line is x equals negative 1. When I get something parallel to the x-axis, parallel to the y-axis, perpendicular to the y-axis, I'm going to draw a sketch. Okay? Because I know all this other information, and once I can see it, super easy. Okay? Super easy. So x equals negative 1. That's the equation of that line. Not a function, but it's still a line. Okay? I'm going to give you guys a couple minutes. I want you to try the next one. Draw a sketch. Okay? Let's read it together. Determine the equation of a line that is perpendicular to the line x equals 5 and passes through the point 2, negative 7 in general form. Okay, so that's ax plus by plus c equals 0. Let's get you set up here. Draw a little sketch of a grid. Okay, it doesn't have to be fancy. Okay, x-axis, y-axis. I want you to start by trying to draw a line perpendicular to x equals 5 through the point 2, negative 7. If you can't do the whole thing, do what you can. I'm going to pause. I want you to pause the video and draw anything that you can draw, even to get a start. Okay? Give it a try. Okay then. So I know you know a lot of stuff, even though you might have read this question and sort of cringed, but we know there's a point at 2, negative 7, so 2, negative 7, which I've plotted. And you know how to draw that line x equals 5. It goes through the value at where x is equal to 5, right? X is equal to 5, so there's the 5, 0. Okay, so I've started with those two items, which I know you guys can do already. You can plot a point and you can draw that x equals line. I knew that that was a line with an undefined slope because I cannot write it in y equals mx plus b form. Therefore, it is not a function, right? That's that x equal type of special line. And now I want to draw a line perpendicular. So if one slope is undefined, the perpendicular slope is going to be 0. So now let's draw our line. Let's find another color here and let's draw that perpendicular line through that point. Okay, through that point. And there's our perpendicular line and we're going through that point. Now, what would the equation of that line be? It's touching the y-axis. It's got a slope of 0, and the y-intercept is -7. So the equation would be y equals -7. Okay? So what looked like a really crazy question with all that perpendicular general form stuff. Oh, general form. We have to change it to general form. And this is in slope y-intercept form. So general form means we need ax plus by plus c equals 0, where everything must, well, the a value must be positive. There's no x value, so a is 0, okay? Here a is 0, but that's okay. We need to make everything over to one side, and so the y is already positive. We're going to move this -7 over, and he's going to become a +7. Now we get a y plus 7. Every equation needs an equal sign. And if there's nothing left on the other side, we put a 0. Okay, and in fact, that is our general form equation. Now, the next question, we're going to skip that. It's a little bit redundant, and we're not doing point slope form, which we would have to start with for this equation, so don't worry about it. Your assignment, okay, you can do more if you want, if you really feel you need an extra practice, but if you were to do and understand the questions from 1 to 6, omitting 1a and 2a, because those are slope point form type questions. Okay, you need a different formula, which we're not using. We're not going to teach you guys, not a big deal. Okay, but omit 1a and 2a, and if you can do questions 1 to 6, you will be a rock star. Okay, I'm also going to complete a video on how to do the assignments for questions 1 to 6, because I know that in class that these are kind of tricky questions, and so what I'll do is I'll create a video for each assignment question and put it all together into one. And if you want to skip a video, you can. If you want to look at like 3C, you can. If you want to look at 4B, you can. But if you don't want to look at 2B and 2C, you can just skip through those. Okay, so a homework sort of solution video will follow. Okay, and make sure you're doing the assignments. You just definitely cannot learn this without. Okay, anyway, I know you're all rock stars at home. You're doing great. You're doing the best you can, as we all are. It's kind of a gong show being at home. For some of us, we're doing great. For some of us, it's been an interesting and crazy time. Okay, I hope you're doing well, regardless of how you're finding the homeschooling and the online homeschooling. But do contact your teacher if you need any help, and I look forward to coming up and meeting you again on the next video.